Hi everyone, this is Devang from the marketing team at Glassbeam. Welcome to the webinar, Keeping Your Data Secure in the Cloud. We're just going to wait a couple of minutes till everyone comes in and gets settled in, and we start the webinar as soon as possible. Thank you. Hi everyone, again, welcome to the webinar. This is Devang Mehta from the marketing team at Glassbeam. Thank you for your interest in our webinar, Keeping Your Data Secure in the Cloud, that we are hosting today with our partner, Dimension Data. A couple of logistical items. All of you will be on mute for the duration of the webinar. If you have any questions, please type those into the questions tab, and we'll be glad to address those in the Q&A session at the end of the webinar. Our presenters today are Ashok Agrawal, the VP of Engineering at Glassbeam, and David McKenzie, the Senior Director of Solutions Architects at Dimension Data. At a high level, the agenda would be to start off by talking about data security in the external network. This talks about how call home data from IoT connected devices is sent into the Glassbeam infrastructure. And then Dimension Data will really talk about essentials of cloud security and infrastructure and how best practices and policies are implemented at their facilities. And then we'll hand it back to Glassbeam to talk more about security at the application level of how security is enforced at different layers inside our platform and how we implement, for example, multi-tenancy to ensure that one customer's data does not bleed over into some other customer's silo. And at the end of that presentation, we shall open up the floor to Q&A. So who we are, Glassbeam is a premier machine data analytics company based here in the Silicon Valley with an office in Bangalore, India. We have been in business since 2009 with really one key mission is to bring structure and meaning to machine-generated data that is emanated from IoT connected devices across the internet. Our team has deep pedigree and experience in the space, having worked at companies like NetApp, Sun Microsystems, Oracle, and Brocade. Our platform today is being used by many premier Fortune 500 companies like IBM, Meru, Aruba, Hitachi, and Dimension Data. And a lot of this is being used across different groups to derive key business intelligence from raw machine data that is sent from IoT connected devices. We have been recognized in this space as a leader in the space by IDC, Gartner, Harbor Research, and other notable publications also. So a little bit more in detail of what we do. Really, our key goal is to take raw data from IoT connected devices and analyze and parse this data and derive powerful insights that can be used to make more informed business decisions. I think the key here is that the data can be in various formats, structured, unstructured, or semi-structured, and it can be emanated by a wide variety of devices like sensors, medical equipment, storage servers, automobiles. Literally data that is sent from any connected machine or an IoT device can be ingested, analyzed, parsed by us and our platform, and we can derive a lot of useful business intelligence that can be used by companies to make informed decisions. So that is an introduction to Glassbeam, what we do and how we do it. That being said, I'd like to hand it over to Ashok, our VP of Engineering.
Hello everyone, this is Ashok Agarwal. I lead engineering team for Glassbeam, and I'm primarily responsible for making sure that applications and functionality that we deliver to our customers is secure, and with the help of our partners Dimension Data, make sure that the data on a cloud is secure. So thinking about how data reaches from your devices to our cloud environment, the first stage for that data is to travel through public networks. That's really the open internet, where the data goes the way you send it. There is no specific infrastructure or any level of security provided in the public network. The only way to, if you really think about it, how data travels in public network is through TCP/IP packets. Now, the networks don't guarantee that these TCP/IP packets are going to go in sequence, or even between the source and target, they are going to follow the same route. So essentially speaking, anybody snooping on the network, it's a miracle that they can make any sense out of this data going through the internet. But still, there could be enough information in one packet which could make your data insecure, such as passwords or things like that, which are going in clear text over the internet. So essentially on the public network, the security is provided by doing encryption of the data. And there are several mechanisms which are available to do encryption. The most common one, of course, is secure socket layers, where the source and the target do a handshake, decide how the encryption decryption is going to happen on both ends, and then go ahead and do the encryption of the data over the internet. Anybody snooping on the internet obviously cannot make any sense out of the data because it's encrypted between the two endpoints. Once the data has traveled through the public network, it essentially comes into a private network, and that's the cloud. The cloud is provided by our partners Dimension Data, and the infrastructure related to that cloud services where the Glassbeam application resides is provided by Dimension Data. We are dependent on them to provide security at that level, and I'd like to invite David to talk about how Dimension Data provides security at that level.
Great. Thank you, and good morning, and good afternoon, and good evening to everybody. This is Dave McKenzie. I run the Solution Architecture Group for the SaaS Solutions Group as part of our IT as a Service business unit for Dimension Data. And I'm going to talk a little bit about, when we talk about security and the different components that each of the as a service type vendors provide to the clients. When you look at this slide here, Dimension Data resides here on the left-hand side, infrastructure as a service. So our focus is on the bottom half of that tier there, and looking at networking and how security is applied to that, and storage, the servers where applications reside, as well as the virtualization that brings all of those things together to provide that environment for those applications to live. In our environments, our clients, such as Glassbeam, are then really responsible for the upper tier parts of those. When you look at the other as-a-service models, platform clients are really responsible for the development of their applications and their data on top of development platform. And of course, SaaS companies such as Glassbeam are really responsible for providing all of that to their clients. So we'll get into really what Dimension Data's focus is around the infrastructure and providing security models on top of that. A little bit about Dimension Data's platform, our managed cloud platform, or our MCP. This delivers our infrastructure as a service, and that is really driven by our cloud control software. That cloud control software really organizes and manages and helps provision the environments for our clients, networks and servers and storage. All of those are made up of the brands that you're familiar with seeing, and really the enterprise class hardware vendors, Cisco, NetApp, EMC, Riverbed for WAN optimization. The operating systems that our clients primarily look to build upon: Red Hat, Ubuntu, CentOS, of course Microsoft. And our virtualization platforms, primarily built on VMware. We do now support the Microsoft Hyper-V in our private MCPs, and then Commvault to help deliver and virtualize our backup as a service products. So all of these come together on our cloud control platform, and all of them have a different component or piece to building that security model for that underlying infrastructure for our clients. The ability to consume our cloud services come in many different ways. Public compute as a service is delivered in 11 different sites today globally. More to come by the end of the year. And that's the ability for you to just go up, swipe your credit card, and start using and deploying infrastructure for your particular application needs. We can also deliver that same infrastructure in a private solution. That can either be in a data center that you own and maintain or in one of our hosted facilities, and aspects of our public cloud that we can make private. So if you do have certain compliancy requirements and or performance requirements, we can take pieces of our public infrastructure and make those private. If you think about the compute layer and the server farms, we can do things of that sort, as well as support our providers, both from a community standpoint and service provider standpoint, for providing these services to them. We also have traditional managed hosting, and that, again, when you look at security aspects and performance, to be able to couple and build hybrid models between our public compute as a service and our managed hosting, again, provides the best of both worlds. A couple more key attributes, and then we'll get into kind of the main aspects of the security. But when you look at what our cloud platform pulls together and really is built upon, we have our different tools that are integrated within the platform, including billing and metering. So again, metering the usage of the infrastructure that's being utilized, SLAs to cover all of that infrastructure that you're operating on, so that you have that ability to deliver that type of value to your clients. The architecture needs to be flexible. Applications all have different requirements that they need, so being able to have a global presence as well as a flexibility to support different needs. Again, security compliance, which is really going to be the bulk of what's going to be talked about in the next slides here. We'll get into those. Our cloud control platform, again, integrates and pulls together all of these different aspects into a single UI. hardware-based networking, again, part of the security model we'll talk about here in a second. The ability to have granular control over your resources. So you can spin up single CPUs, single amounts of RAM, 16 vCPUs up to 128 gigs of RAM independently. So you're not tied to a single image size, or if you adjust one, having to then live with whatever CPU or RAM that's tied to that. You can fine-tune those based on your workloads, fine-tune those independently. And of course, all of this comes together in a UI, as well as all of the aspects that are part of the MCP are also accessible through an API. So you can automate the deployments of networks and adding of firewall rules and servers and things of that sort. Okay, security. When we talk about security at the infrastructure level, what our clients are relying on us to do, and our focus, is around, again, those last pieces of that first slide I showed you in the network and the servers and the storage, again, virtualization, tying all that together. It really encompasses all of these bullet points here. Compliancy. So being able to ensure that the process and procedures and how we've architected everything come together to meet the compliancy and security requirements that you have, depending on the market you're in or the data that that's residing on our cloud platform. Account-based security, knowing who is logging into your cloud environment and making changes to those environments, and being able to segment, have those roles and responsibilities defined for the different types of people that are going to be managing your environment is important, which hits really that next bullet point, and being able to audit, being able to know when someone deletes a server, when someone changes a firewall rule, so that you have that logged. And again, those logs go back to compliancy, being able to ensure you know who's doing what, when, and where. The facility, obviously the facility needs to be secured, and we'll talk a little more in detail about what that looks like, but those are definitely things that you can't always assume. You want to make sure that you have, that you understand how the physical facility is secured and protecting your data in your environment. Data security, obviously the ability to encrypt data and be able to have authentication methods that allow you to ensure that that data is under your control and not being able to be parsed and taken. Secure access to the environment, being able to administer the environment is important. All of our clients, when you have a username and password to our environment, you have a VPN assigned to you that allows you to get in securely to your environment to then start to administer your software, your servers, install your software, etc. The perimeter security, this is now getting into your typical firewalls, IDS. All of those things need to be part of your environment. It's great to have other aspects of security. If you don't have these things on the perimeter, you're really missing a huge part of your security model. So we have those available for all of our MCPs worldwide. And again, network-based security, the ability to have dedicated VLANs. So not when you deploy servers, you're deploying them onto dedicated VLANs for your environment. It's not a flat layer 3 network where all clients that are using the cloud environment are residing on, and then you have to secure your server environments. These are dedicated VLANs with their own firewalls, load balancing built onto them for that type of protection. So we'll get into the details of each one of these. First one, security of the facilities. So the ability to have a secure facility against physical access. So your ability to ensure that the environment is protected with video surveillance, so closed circuit video, and being able to have access to that video. Those are things that we ensure our data centers have available to us, ensuring that there are on-site guards on the environment, checking people in, multiple layers of access into the environment with biometric scanners, and again, two-factor type authentication to get in, not just into the facility, but into secure environments and then into secure cage spaces. So multiple facets to be able to get into environments is also part of what you want to make sure is standard within the facility that your environment is residing in. From a failure standpoint, we want to ensure that those data centers have all of the power and environmental controls to ensure for any type of power outage or environmental things such as heat. Obviously, you don't want your environment to be under the attack of a hot environment and have servers fail on you. So all of the environmental controls are critical, and those are security aspects to ensure that the environment's uptime is reliable. And then your typical fire detection, ensuring that from any unforeseen issues within the data center, that the environment can protect itself under fire, floods, earthquakes, all of those types of natural disasters that can happen. Our cloud networks are an important part of our security model. The genesis of our cloud service really was born out of a lot of experience hosting SaaS applications for many years in our managed hosting environments. And so we had a lot of experience around this, and it was really one of the main pieces to building our cloud infrastructure as a service environment. And when you look at, again, we deploy layer 2 VLANs for our clients, and this is important so that you don't have to, you're not adopting shared firewall rules. You want to be able to customize the deployments of your firewalls and be able to deploy network segments to build whatever security from a network architecture standpoint that you need. Relying on the firewalls and load balancers that are part of each of those VLANs, and be able to customize those to your liking. Quick snapshot of the types of environments that we've built. I mean, a lot of applications and a lot of our clients are at least 2-tiered, some are 3-tiered, and the ability to quickly deploy multiple network segments and adjusting the firewall rules to meet that level of security for that network segment. Your front end, your DMZ, being able to open up the ports and secure that, but allow the access in from the internet, and your users being able to come into your front web tier, authenticate through, and then pass it through another set of firewalls to get into possibly that application layer. So that your application can now start to then communicate and get queries through another set of firewalls to your database tier. So being able to build complex network environments within a cloud quickly and easily, the same way you would do this if you were deploying this within your own environment, was really important when we were building our cloud product. The ability to NAT and again have multicast as part of those functions of that network is another important part. If the application requires those types of functions, having that available to our clients through the UI or again through the API was very important. Back to our cloud control, which really is that management layer that is providing the provisioning, the capability of pulling together all of the different aspects that make up the underlying infrastructure into that single UI. It's multi-tenant, so it does have the security levels, and we'll hear more about that when we pass it back to Ashok to go through the application level securities. But having that function within the environment, the ability for that environment to also manage and work with our IDS solution, so protecting against DDoS, which is obviously critical when you have applications that are exposed to the internet. That is part of our overall security model on all of our global MCPs. Obviously, you have to also have the team to manage all of that, and we do with our incident response team that is monitoring 24/7, responds to any type of security issues, and maintains and manages all the network environments, VPNs, firewalls, etc. The account-based security and management, if you're building an environment, you're going to want to make sure that you can have segmentation of the roles and responsibilities of who has access to it and what they can do. So if you have a network administrator, you're going to be able to secure access to have them only manage network aspects. Server administrators, you probably don't want them to be able to change firewall rules, so you can provide levels of segmentation and certain roles to different sub-administrators within your cloud environment, and be able to ensure that they have secure access into the UI as well as secure access into the servers to be able to administer those and fine-tune those at the local server level. And then tying all that is being able to have that audit trail to go back and see. Many times you'll have someone who may change a firewall rule, and you want to be able to see who did that, when they did it. That will all show up in the audit logs, and those audit logs will be available and can only be available to that primary administrator. So you can have that person who is responsible for ensuring that the environment is properly being utilized by only having that person having access to those logs and being able to see who's doing what. This also logs any type of UI access, API access to the environment. So if you're using the API will still be logged in there. So you'll know if the API call made a change to a firewall rule or deleted a server, stopped a server, something of that sort. And then all of this really ties down to what we're trying to support, and that is compliancy. Many of our clients are in medical, financial, other sectors that have strict compliancy around storing of data and or the processes around how they're managed. So when you look at SSAE 16, formerly SAS 70, having that is critical. It's basically the minimum of what we really need to have to make sure that your processes are not just documented, but they're also audited to make sure that you're following those processes on how that environment's being managed. PCI, for those in the financial or those taking credit card information and have to comply with PCI, having a company and having an infrastructure that understands how to support those requirements, two-factor authentication, IDS, host-based, antivirus, all of those types of aspects that fall under PCI, you're going to rely on your infrastructure provider to have to provide those things. And then safe harbor, as well as HIPAA, being able to have an infrastructure provider stand behind and sign BAAs is critical for those in the medical market and storing client information. All right, that finishes the dimension data section of this, and I will pass it back to Ashok.
Thank you, David. So we saw how, and really SaaS application providers like Glassbeam depend very heavily on the infrastructure backbone provided by the cloud providers, without which we won't be able to build upon that and go beyond that in order to keep your data secure. So we looked at how Dimension Data provides security at the cloud level, and the next stage from that is really where the application starts. An application typically consists of multiple sets of servers, and David talked about virtual LANs to a certain extent, and Glassbeam uses virtual LANs to sort of distinguish between different components of the applications to make sure that virtual LANs are typically isolated from each other from visibility perspective, and we as an application provider make sure that the server access is controlled by rules of those virtual LANs. So first component of the application is, of course, externally facing servers which are in the DMZ, but even at the DMZ level they are not 100% open to public attacks. They are network address translated, those services which are provided again by the cloud APIs. Also we use ACL rules to make sure only the necessary ports are open into the machines which are in the DMZ. And these are typically like web servers, SFTP servers, which are receiving log files from IoT devices, email servers, which are receiving logs through email, and so on. And then the backbone of the application really is the servers inside the VLANs, which provide all of the parsing rules, all of the databases, and all of the other backbone of the application. And these are really inside VLANs which have no public access at all. There are no public IPs through which they are exposed. They are only connected to the DMZ servers through a new set of ACL rules, which ensure that that only those ports which are needed by the application are open to it. As you can see, infrastructure providers don't know what port and protocols your applications are going to use. So obviously they leave that level of security to be implemented at the application level. So that brings us to the most important part of security, and that's really application security. It's really three-phase security. One is securing the network, second is securing the hosts, and third is securing the application. Network security, we already heard Dimension Data talk about how they provide infrastructure security at the infrastructure level, and the other two are application level things, which I'm going to touch upon a little bit. So really, barring somebody who has a bone to pick with you, walking away with hard disks from your infrastructure, there is majority of the data breaches really happen when somebody hacks into your network. And again, hacking is all about gaining unauthorized access. There are multiple ways people hack into your systems. Typically, network communications happen between two machines through a protocol. And protocol communicates over ports, which are also called sockets. Now, protocols are things like HTTP or FTP or SFTP. And protocols basically identify a handshake mechanisms for two machines to talk to each other. The only way you can get access into a machine is really through a port, because those are the only things which are open to the internet. Ports can be insecure or they can be secured, and typically hackers will look for insecure ports through a rogue program to try and get into your data, try and get into your network. As I mentioned, infrastructure providers can only go so far. Most of the ports which are open over the internet would have some kind of protocol handlers listening on those ports. So for example, if you open port 80 to allow web traffic, you'll typically have a web server listening on those ports. That process is called binding to those ports. And these protocol handlers, many of these protocol handlers have well-published vulnerabilities. And essentially speaking, these are the vulnerabilities which the hackers will try to use to try and get into your, sneak into your application. So these are not just insecure ports, but also known vulnerabilities into these listeners. Believe me, there are publicly available lists of known vulnerabilities for different components like Apache, IIS, which are known to these hackers, and they exploit these to get into your applications. How do you prevent hacking? Primary way of preventing data loss is to make sure that your servers which are on the DMZ are hardened. What does hardening mean? It means basically don't expose services which you don't want to use. Don't have listeners on ports on these servers for which services you don't, your application doesn't need those services. If you don't need telnet, don't open telnet ports. If you don't need SSH, don't open SSH ports. So that's one process of hardening. Most of the times we would have a default access policy of denying everything. There is nobody allowed to access the servers except the ones who are allowed to access. And then the final part of hardening is to make sure that all security updates which are provided by the OS manufacturers are applied to your servers. And that's again the responsibility of the DevOps of the application provider to make sure that the servers are up to date on their security patches. Use access control lists. These ACLs define what ports are open, what IP addresses can access those ports. Don't have things which are open to all ports, all protocols, those kind of scenarios. Linux machines allow IP tables, which provide a further level of redirection or a further level of security. They will define ports and protocols which are accepted by that server. They can also implement IP ranges from which those protocols are accepted. Deny hosts is the third-party list which is maintained. These are updated periodically. Anybody who's trying to access or gain unauthorized access are handed over to these deny host lists so that any further attempt from those hosts are not accepted on your system. The main thing is don't allow any root logins into your system, which we do as a rule. The only access is through public-private key pairs. Anytime when our customers have to drop files, log files onto our system, we will ask them to create public-private key pairs, and we will deploy those public keys on our servers. And when they are dropping files, those public keys have to match up with a private key before they'll be allowed to access the systems. And these are 2048-bit keys. I mean, and I dare say it's impossible to break these keys. Then comes the application level security, which is basically securing the application. Again, knowing what vulnerabilities exist in the components which are being used in your application is the key to it, so that you can build logic or rules to prevent those kind of vulnerabilities. Scrub user input. You must have heard about SQL injection or user input which can really attack your databases. So build application rules, application logic in a manner that you scrub all of the user input. Don't accept any user input as such which can harm your data or which can harm your application. Don't use insecure protocols. Don't use FTPs or other similar kinds of insecure protocols which are not encrypted over the public network. And then finally, authentication, authorization, and audit. We make sure that people have proper logins, user ID logins, and not just that, we also make sure that the data which they are accessing, they are authorized to access that data, which is implemented through rule-based authorization, making sure that all functionalities of the application are not available to all users from the customer side. And then audit is to make sure that people generating usage reports on a periodic basis to make sure who is accessing the application, what functionalities they are accessing, how often they are accessing, and whether they are authorized to do so or not. Finally, on the storage level, there are multiple ways to secure data at the storage level. You could talk about data obfuscation, where you make sure that all of the related data is not saved together in a single table or a record. You do data encryption, typically done for passwords. When you talk about multi-tenancy, you do tagging of data to make sure that, again, users who have access to a specific type of data can only access that data. PCI and HIPAA compliance, but then again, don't go overboard in doing those kind of things. I mean, if you're not really using credit cards in your applications, then you probably don't need PCI compliance. Similarly, why bother about HIPAA compliance if you're not going to handle patient identifiable information? Final stage of any SaaS application is multi-tenancy, and people are generally concerned about bleeding of data across different tenants on the application. So Glassbeam uses a very, very hierarchical tagging algorithm to make sure that all the data which gets in, even before the application handles it, at the data level itself is tagged to the hierarchical format, So any device which is sending data is ch-rooted into a particular directory, and which means as the data gets into the system, it's already tagged. It's impossible for that data to lose that tagging as it goes through the application. Then all of this application is processed by the Glassbeam applications, and then it's stored into a multi-tenant database, which again implements all of the tagging algorithms. So the data is already tagged before it goes into this multi-tenant database. On the retrieval side, the data is partitioned at the database level into the different tenants, which are which have data on the database. And again, that partition is done on the basis of the tagging algorithm which is used by Glassbeam. On top of that, users who are logging into the system have, as I mentioned, they have user ID passwords. These user ID passwords are also tagged to specific tenants. That means as soon as the user logs in, they are sandboxed into that specific data. So they cannot access, the database is not going to allow them to, and the application is not going to allow them to access any other data which hasn't been tagged for their specific use. So not just the login ID, which is login ID password, which is authenticating them, they're also authorizing them to use specific functions, but it's also making sure that they can only access data for a given tenant. And that's how we make sure that the shared environment can be used by multiple tenants. So overall, in summary, we looked at security in the public cloud, the TCP/IP packets, the SSL certificates, which are used for making sure data on the public cloud is encrypted and not available to a casual snooper. We looked at the cloud infrastructure. Our partners, Data Dimension, showed how they provide security at the infrastructure level, so to make sure that the cloud is secure. And then finally, we looked at the application level. How do we secure the hosts? How do we secure the applications? And then how do we secure the database? And then finally, we also looked at security at the multi-tenant level to see how data is secured across tenants. At this point, I'd like to open up the floor for any questions if you have. I see a question here from how is your data center physically secured? I'd like our partners Dimension Data, David, if you'd like to take that.
Sure. Again, it's really done at multiple levels. You want to make sure that the outside of the data centers, the perimeter is secure through fencing, through cameras, and then getting into the physical access to the environment or to the building, and then into secure environments and secure cages. You want to have multiple levels of two-factor biometric scanning devices to ensure that you know who comes into the facility, who goes out of the facility, and then you want to maintain those logs. You want the access to be logged, and you also want to be able to maintain the permissions of who can have access all the way into the environment. So the vendors aren't in there, customers aren't in there. It's really just the infrastructure team that has access to it. So roles and responsibilities, as well as the ability to have those physical devices in front and in video surveillance are critical to the physical security of the environment.
Our attendees would like to know, how do you secure virtual machines in your cloud? David?
Sure. There's a lot of aspects to doing that. We leverage obviously our virtualization technologies utilized, so VMware, and being able to have those machines that are, when they're built, they're assigned to those clients. Those clients, when they build them, provide the root passwords to those machines. Those are not kept by us. Those are maintained and developed by each of the clients. So the client has that root access, our administrator passwords and usernames. They're sitting on dedicated VLANs. So the network security is about securing those those virtual servers as well. And then you look at the storage tier and be able to have those, the LUNs that are created to support the storage for those virtual servers being, again, secured and only accessible by those virtual machines created by that particular client, down to all the role-based permissions that are assigned to the environment.
Another question: who at Glassbeam has access to the customer data, and how do you restrict this access? So as I mentioned, the data comes directly from your devices and goes to the Glassbeam cloud, which is hosted at Dimension Data. The Glassbeam team doesn't really get to see that data at all. The team has no access to this data. Only DevOps and people who are responsible for the servers will be able to look at the machines. They are the only ones who have access to this machine. So, but they have no really reason to look at the data at all. So typically speaking, the data comes in, it's processed by the Glassbeam applications and goes directly into the multi-tiered tagged database environment. From there, it goes through the middleware into the applications, into the analytic applications provided by Glassbeam, from where it goes back to the end users who are really using those analytic applications to derive business intelligence. So that's the cycle of data. Eventually, data is obviously archived at the Glassbeam level also, but again, the Glassbeam team has no access to this data. How do you uniquely identify a packet of data by device, customer, etc.? So as I mentioned, we have a tagging algorithm to tag every piece of data coming from a device. It's a hierarchical tagging algorithm which allows us to tag a data in a manner that the access rules can then simplify that access. So we have a 4-tier hierarchy for tagging the data. The data is tagged for an end customer. Now we are working with IoT manufacturers who have end customers. So most of the log files will have information about the end customer. So we are tagging it for end customer, then we are tagging it by manufacturer, we are tagging it by product. So we could be working, say, for example, multiple products for a manufacturer. So the data is such tagged by these 3 levels. So if a manufacturer wants to have access to the data, they can have access to all the data for all products. If an end customer wants to have access, they can have access to all their data from this manufacturer and this product. Similarly, people who are authorized to view data for a given product only, they will have access only to that product specific data. So as we look at data being tagged at these 3 levels, similarly, the users who are coming into the system are also tagged at these 3 levels, and they can only have access to that level of data which they are authorized to use. Do you provide backup and restore services, David?
Yes. Yeah, we have a backup as a service product, so you have the ability to, for each of the servers, define a different backup policy, depending on if you want to back up the data, the application state, the operating state, of course, obviously all of them. So you can define those based on each server. That data is backed up and encrypted in flight as well as at rest, and we do have the ability to off-site that, so you can have that data reside within the cloud data center that you're in, as well as replicate that to one of the other facilities within that geographic region.
What method to send in log file data is the most secure, and why? So there are multiple ways of sending data. Of course, the data can be tarred and zipped into a file and sent over email. Some of our customers do that. The data could be sent over FTP, or rather SFTP. We don't recommend using FTP at all because it's insecure. SFTP is acceptable, and there again, the SFTP data is dropped into a login directory, which is, as I mentioned, CH rooted into a specific user ID, or rather a public key through which this data can be dropped into the system. In addition to that, we have recently started working with streams. Streams are real-time connections between a source and the target. So this data comes over either syslog protocol or SNMP protocol or whatever other protocols the customer deems necessary, and that data comes directly from the source over the internet, either over UDP or TCP, into the Glassbeam parsing servers. So SFTP, secure email, SCP, or streams are the mechanisms through which we recommend sending data. Do you provide dedicated physical or virtual LANs to your clients? David?
Yeah, it's an interesting question. Really, the networking services are provided by dedicated network equipment. So the network is provided by network equipment. These are not virtual servers providing those features and functions. So physical devices provide the VLANs, or those virtual LANs, to each of those clients. Those VLANs are dedicated to each client. So when you deploy a network or a VLAN, that is dedicated to you. There's no other network traffic on that VLAN. There's no other clients using that, pre-assigned ACLs, any of that. So it's physical devices providing the network services, and then dedicated VLANs for each client.
Another question here is, you obviously take compliance extremely seriously. As part of your service offerings, do you have remediation managers to take up the results from the scanning and a subsequent process to remediate and or capture and sign off any business case justifications for customer agreed exemptions and associated risks? In addition, what measurements are applied to the scanning tests? Are these against a particular industry criteria? I'm assuming these scanning tests are DDoS and these type of scans?
Yeah, I guess. I mean, it could be a number of different things. We look at from a compliancy standpoint, those that are scanning the environments for penetration tests or vulnerability scans or any of those types of things. We work with our clients on those, especially if we're part of some type of management arrangement. So those tests that either we're doing as maybe part of a PCI environment, those tests are provided back to our clients as part of that PCI. Our clients are providing some of those scans. They're doing some vulnerability scans of their application, so application-specific type scans of their environment that are part of maybe some compliancy. The IDS and the IDS solutions that are in place, we do provide some of those scans as part of, again, if we're providing, say, PCI services to a client. The normal and general IDS that we're providing for the environment as a whole is not provided directly to our clients. But again, through services, we do provide different types of scans as part of some type of certification or compliancy that our clients are contracted with us and have to maintain.
On the application side, business case justifications for customer agreed scans and exemptions, we haven't had any use cases for this where our customers may have asked us for doing any specific scans, but we'll look at them for sure. But we'll obviously make the customers aware of any associated risks of doing that. The only things I can think of are really SQL injection tests or security penetration tests of different kinds. In a production environment, obviously, it's part of it is related to infrastructure, which David already talked about. But from an application perspective, like I said, if a customer has a specific requirement, then we'll certainly take a look at that. How do you back up application data? So at Glassbeam, we have multiple types of backups. Obviously, once the log files get into the system or the streams get into the system, once they are processed, they are saved and archived into a low visibility storage from where they can be retrieved and reparsed if necessary. And at the same time, database is also backed up on a periodic basis. Either delta backups or full backups are taken on a periodic basis to minimize the recovery time should a catastrophe arise and should a need to recover a database arise. Do clients have visibility into their virtual machines and servers running in their cloud? And if so, what monitoring tools do you provide? David?
Sure. There are a lot of different ways to monitor the environment. Yes, clients have direct access into their virtual servers so that they can monitor them with any tools that they want to provide. If they're used to having a certain tool set, those can definitely be monitored and set up and established. We also do provide monitoring if we're contracted with services. We do provide monitoring for a few different things, system level. So again, health of the environment and ensuring capacity requirements for the client's environments, as well as transactional or URL-based monitoring to ensure the application is properly working. So again, underlying system health is great, but if the application itself has issues, you want to be able to monitor that as well from exterior points. So we do have the ability to do that as well through our partner, Nimsoft.
How do you prevent customer data from bleeding over from one silo to another? That's critical for any SaaS provider. The benefits of SaaS really come from sharing of the infrastructure, and that includes the database and the processing environment which is processing the data. It is absolutely critical for any SaaS provider to make sure that customer data does not bleed over from one silo to another. And as I mentioned in my previous presentations, the tagging of the data is a critical component of providing this assurance that the data, as soon as it gets into the system, is tagged, and then as it travels through the system, it stays tagged and it goes tagged into the database. Similarly, users who are authorized to access the system are also routed into or tagged into a specific end customer, manufacturer, product hierarchy, so that they have access only to the data specific to that environment, to that silo. Any other questions?
Okay, that's a really interesting discussion. I think we're coming up to the top of the hour. I wait one more minute for any last minute questions that you might have, and okay, we don't have any other questions. So on behalf of Glassbeam and Dimension Data, I'd like to thank Ashok and David for this really interesting presentation, really informative, hopefully for all of you, to answer apprehensions that you might have about data security in the cloud, both at an infrastructure as well as at an application layer. This recorded webinar will be up on our website and Dimension Data's website in a couple of days, so you can definitely access it if you've missed anything or you came in late. But aside from that, thank you so much for your interest in our webinar, and this concludes the webinar. Thank you.